Okay, so you've made it back from Lago de Oro, having completed your field work and got all your data. Um, we now need to take a look at all the data we collected here along the environmental transect line at each of our systematically sampled points 100 meters away from this human settlement here, away from human activity and settlement towards the mangroves here. And what we need to do then is we need to actually do a couple of things. We're going to go into Microsoft Excel and we need to input our data, just as I've done. We've got the data for all of our sites ranked from the area nearest to human activity, which I'll just label here, and let's just call this nature. So this is the one nearest to the human settlement, this is the one furthest away. Now our hypothesis states that environmental quality will improve as we move away from human settlement. And one of the indicators we've got is nitrates. So we assume here that it's going to get better. And if you look at the data, it does seem to suggest that from 0.444, the highest reading near the human settlement, to 0, which is the furthest away from there. Okay, so what we need to do here is we're going to use the data section of Excel, and I'm going to use the data analysis section. We need to take a look here, sorry about the noise, and choose correlation and select OK. Now the input range of data is, let me just juggle these about, is going to be here. Okay. Now the output range of data doesn't really matter. Oops. Let's see. Will be, why are you doing that? Output range, okay. Is going to be here. And then we're going to press OK. Now, what that's done is it has calculated what we'd like to call, what we will call, and it is called, the Spearman's rank correlation coefficient. You probably won't understand what that ranking is, but essentially what it's doing is it's testing if there is a correlation here and if it's going to be statistically significant. Now, in order to see whether it's statistically significant or not, what we have to do is we have to go with our 0.6, let's just call it 0.62 figure. And we have to go to, let's search for, in Google, Barcelona fieldwork. What it takes you to is it takes you to, gives you this option here, Barcelona field studies. Now, within that site there's a search bar, Spearman's rank, and then we're going to search the site for Spearman's rank. Now what it will do, it gives us this option, and we have now got the Spearman's rank correlation coefficient information on their Geography Fieldwork website. Now it's just an explanation of how you do the whole thing. The important point from our point of view is this table, or this graph in fact. Now what it's looking at is how two variables intersect. Now it's the degrees of freedom, that's the number of pairs of items in sample minus 2. If we go back to our data, we've got 1, 2, all the way up to 14. So actually with 0 we've got 15 pairs of data. So what we're going to look at is we've got 15 minus 2, 13 degrees of freedom. So we're essentially about here then, right? Now our figure was 0.62, so we are 0.62 and then 13 degrees of freedom, which is just about where the arrow's pointing now. The good thing is that that means that we're beyond this red line, we're further to this side of the red line, which means we're 95% sure, there's a 95% statistical probability that the correlation that we've experienced is actually totally acceptable, because the minimum level of acceptability is 95%. The good news, folks, is that this means our data for nitrates for our IA is actually statistically significant, so we can start to look at the reasons why that might be the case. Well, basically it confirms our hypothesis, so good news.